You know, battery technology is really at the core of this huge global transformation we're seeing. From electric cars to renewable energy, pretty much everything hinges on having powerful, safe, and affordable ways to store energy. And believe me, the race to define what that future looks like is really heating up.
For what feels like forever, lithium-ion has been the undisputed king of the hill, right? But the big question now is, what comes next? So in this explainer, we're going to look at the two leading contenders ready to take that crown and completely reshape our energy world.
So, the future here isn't just one straight line. Think of it more like a fork in the road. While lithium-ion is still the benchmark we measure everything against, the industry is really splitting its bets between two very different but very powerful new ways forward.
Okay, so on one hand, you've got solid-state batteries, the high-performance contender promising to just shatter our expectations for range and safety. And on the other hand, there are sodium-ion batteries, the affordable, sustainable workhorse designed for the mass market. These aren't really competitors so much as they are two different solutions for two very different and very massive challenges.
All right, first up, let's dive into the one that gets all the buzz, solid state. This is the technology that car makers are betting on to finally wipe out range anxiety and make electric vehicles the undisputed champions of performance.
So, what's the secret sauce here? Well, it's actually kind of simple, at least in concept. You take that flammable liquid electrolyte inside today's batteries, and you swap it out for a solid material. That's it. But that one change, it unlocks a whole cascade of incredible improvements.
And the benefits are, well, they're huge. Because the electrolyte is solid, you can pack everything in way tighter, which boosts energy density for a lot more range. It's not flammable, which is a massive safety win. It dramatically cuts down the fire risk. This solid design also means you can charge way faster, and it can handle more cycles, so the battery lasts much, much longer. It's really just an upgrade across the board.
So what does this actually mean for you in the real world? For an EV, we're talking about a range of over 1,000 kilometers. That's over 600 miles as a realistic target. And charge times could plummet to under 15 minutes. This isn't just a small step up. This is a total game changer.
But you knew there had to be a catch, right? The material science behind this is just incredibly complex, which makes them super expensive to produce at the moment. And figuring out how to scale that up from a tiny lab to millions of cars, that's the biggest hurdle of all. It's why we're probably going to see these in luxury cars first.
Okay, so let's switch gears and talk about our second contender, which is coming at this from a totally different angle. While solid state is all about chasing that ultimate performance, sodium-ion is all about ultimate accessibility. This is the tech that could truly bring energy storage to the masses.
The idea here is pretty much the same as lithium-ion, but with one massive substitution. Instead of lithium, it uses sodium to carry the charge. And why is that such a big deal? Well, sodium is basically everywhere. Think table salt. It's one of the most abundant elements on the planet, and it is dirt cheap.
And that simple switch gives us some huge strategic wins. It slashes costs, and crucially, it breaks our dependence on those tricky lithium supply chains, making the whole process much more sustainable. And hey, as a nice little bonus, sodium-ion batteries actually work surprisingly well in the cold, which has always been a weak spot for lithium-ion.
Okay, so there is a trade-off here. Sodium ions are just bigger than lithium ions, so you get less energy density. That means they probably aren't your first pick for a high-performance, long-range EV. But for things where cost and durability are king, like massive grid storage systems or affordable little city cars, they are absolutely perfect.
So we've got these two amazing technologies on the horizon. But what's really pushing all this innovation forward so incredibly fast? It all comes down to two gigantic, interconnected markets, electric vehicles and grid-scale energy storage.
When it comes to electric cars, the main driver is simple. It's all about cost. I mean, look at this. The battery alone makes up a massive 30 to 40% of a car's entire price tag. Getting that number down is the absolute key to making EVs affordable for everyone.
So, the roadmap for the next generation of EV batteries is crystal clear. The whole industry is laser-focused on these four things: packing more energy into a smaller space, charging them up faster, making them last longer, and doing it all in a way that's better for the planet.
But you know, there's this other massive driver that doesn't get as much attention: the energy grid itself. If we're serious about renewables, we need absolutely enormous batteries to soak up all that solar and wind power for when the sun isn't shining or the wind isn't blowing. These giant batteries are what will keep our grids stable and make a clean energy future a reality.
So, where does this all leave us? We are literally stepping into the most critical decade in the history of energy storage. The decisions we make and the technologies we choose to scale up in the next 10 years will define our world for generations.
At the end of the day, this isn't really a winner-take-all situation. While solid-state might be the ultimate technological leap for high-performance cars, sodium-ion could completely conquer the mass market based on pure economics. The race is definitely on, because mastering this tech isn't just about building a better product, it's about shaping the world of tomorrow.